Hey, everybody, welcome back. For those of you that are in class already, it's been all of fucking 10 seconds. For those of you watching videos, we're starting 4.3, which is on graphing rational equations. Or graphing rational functions is a better.
Oh, sorry, I meant to ask also, for this test that's coming up, you're also gonna have chapter 4 stuff in there too?
No. No. Just chapter 3. The idea was give you guys time to actually do the stuff. Make sure you're up on your game for that, but no. Chapter 4 will have its own test. In the future. Alright, graphing rational functions. For example, f of x equals 1/x minus, we'll say a. Rather than pick a particular point, we'll say x minus a. So our domain is all values except a. Couple ways of writing that, x does not equal a is probably the simplest and most concise way of showing it. But if you're working with a teacher that's very picky on notation, this is negative infinity up to a in union with a to infinity. That's another way of showing it, that's interval notation. X equals a is a vertical asymptote. We can see that doing limits. So let's look at the limit as x approaches a from the left. And limit as x approaches a from the right. Wait, so that's right, that's left. So if we go from the left or from the right, a plus is a little bit larger than a. So this should be a positive number down here. I don't know, something like that. This is going towards positive infinity. If we approach from the left, a minus is a little less than an a. So the denominator should be negative. And we're going towards negative infinity. So approaching from the right, we said we're going up to positive infinity. And we approach from the left, we're going down to negative infinity, so we can see that. What about if we do when x approaches plus or minus infinity? Limit as x approaches negative infinity of 1/x minus a. And limit as x approaches positive infinity of 1/x minus a. This ends up being like 1/negative infinity, which is going to 0. And this is like 1/positive infinity, which is also going to 0. Which means the graph is doing some shit like this. Since this was f of x, f of x equals 0, in this case, is a horizontal asymptote. . . 。. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Vertical asymptotes cannot be crossed. They are a hard barrier. You've seen the movie Tron, those are the Tron cycle lines. You don't fucking cross them or your ship blows up. If you haven't seen Tron, that's completely meaningless.
It's like almost like a big snake, right? You can't hit yourself.
Yeah. Horizontal asymptotes can be crossed. They show behavior, they show end behavior. Which is where they don't get crossed. So in the middle of the graph, you can cross the horizontal asymptote all you want. Horizontal asymptotes are really more about what's going on as you go to the negative infinity or positive. And to find a horizontal asymptote in general. I'm gonna call these VA for vertical asymptotes, and these will be HA for horizontal asymptotes. Cause that's a fun, a lot of letters to write, and it takes time, you're gonna get tired of filling up your page with shit like that. Finding HA. Limit as x goes to infinity. Of f of x. If it equals L. Then y equals L is your HA. And I'll say plus or minus infinity, should be the same on both. Well, that's not true. Usually. For x towards positive infinity. And let's say we had a different one, usually this does not happen. But if you had like a piecewise function, it might happen. Then y equals m is your HA. For x to negative, going to negative infinity. I don't know that I've ever seen them different. So they should only really be different for piecewise functions. But in case you have it, piecewise function. That's what rational functions are in the asymptotes. There is another set of asymptotes. They are called the oblique asymptotes. Oblique or slant asymptotes. And curvilinear asymptotes. Maybe I should have started this on the next page and give you room to like actually write what they are. So horizontal asymptotes are the degree of the denominator. The degree of the bottom is greater than the degree of top. Well, greater than or equal to. If it's greater than, your limit will be 0. If the degree of the bottom equals the top. For example, something like f of x equals 2x plus 3 over 3x minus 2. If you do the limit here, limit as x goes to infinity. This is a L'Hopital event. And we take the derivative. And you see we get 2 over 3. So when the degree of the bottom equals the degree of the top. Your limit is the fraction of the leading coefficients. The leading coefficients. The 2 over the 3. You don't need to memorize that. If you just take the limit, you'll find it. But if you like memorizing shit like that, there you go. So here y would equal 2/3 is our HA in that example. Then we get to our other category. If the degree of the top. Is. 1 greater than the bottom. Here you get an oblique or slant asymptote. And if its degree of top is 2 or more greater. It's called a curvilinear asymptote. And both can be found with. Division or long division. You need to do the long division. And we'll do some examples, you'll see what I'm talking about. So. We're talking about graphing rational functions, let's go just like we had some steps that we did before. Since we're gonna call this curve sketching. That's the general name of graphing these things. kind of list did I get last? Maybe I should have on the fly. Talked about the intersects, the current, yeah, okay. Find the domain. And find your intercepts. These are important. I'm gonna say this one is optional, the next step. Consider symmetry. Like for odd functions, f of negative x equals negative f of x. It can make graphing easier. But in general, you don't, this isn't all that helpful, but it can help you determine. If your graph looks like bullshit, like you fucked it up. In today's day and age, you'll probably just check it on Desmos, except on a test. Three will be find our asymptotes.
And is that both the horizontal and vertical?
Yeah, I'm about to break this down into categories. A, do your vertical asymptotes where the denominator equals 0. And then B, horizontal. Or. Oblique. Using division or long division. Now, all of this stuff you actually learn how to do in algebra, presumably. Even the obliques, we didn't really call it limits before, but we're like, what's happening at the end? And we did everything but use the word limit in algebra. But you can do it with easier with looking at limits now. Now we need our critical points, so find the critical points. Regions of increase and decreasing regions. That kind of helps us find our extrema. Or max and mins. So that's some first derivative shit, right? This is where we're doing more calculus, we're doing that with our first derivative. And 5 will be. Find concavity. Intervals. And inflection points. And this is our second derivative stuff. After that, sketch that bitch. Like all of this really applies to the polynomial function except for 3. So like, step 3 was the new addition for rational functions. If you use this list for any type of graphing. You might just end up skipping over asymptotes, because it doesn't have any asymptotes. But the list would be the same for all of it. Alright, let's do an example, everyone looks like they're done writing. Let's take a look at f of x equals x squared. Over x minus 2 squared. And I'm gonna expand that out on bottom, because I think it's gonna help us in a second. But the first one helps us find our domain. So the domain. X cannot equal 2. Every other value should work. So if your teacher's picky. Negative infinity to 2, union with 2 to infinity. I'm okay with like x doesn't equal 2. As long as you know how to do the intervals and read them. If you don't do it on the test, I'm not gonna break my heart. If you don't know how to read them, you're eventually gonna be fucked. Cause some teachers are only gonna use it. That actually will show us where our vertical asymptote is. Our vertical asymptote should be x equals 2, that's a later step, but. It revealed it right now. X intercepts. Or where y equals 0. This can only occur where the numerator equals 0. Which is at x squared equals 0 or x equals 0. So we have the point 0, 0. Y-intercept x equals 0. 0 squared over 0 minus 2 squared. Is 0 over 4, which is 0, so same point. We only have one intercept. So maybe I'll make a little box, start listing shit. Our intercepts are 0, 0. We can see that our vertical asymptote is x equals 2. Do we have any horizontal or oblique asymptotes? Let's check the limit as x goes to infinity. And this one's probably a little easier to do on this one. That's gonna be infinity over infinity, so we need a L'Hopital. Well, there's another way that speeds it up, but. If you practice L'Hopital, it'll help you. Which is also infinity over infinity, which will give us another L'Hopital. So we have a horizontal asymptote. Where y equals 1. I didn't put this on the list, or maybe I should have. We can find. Where our graph. Crosses the horizontal asymptote. By setting. F of x. Equal to that limit. And solving. So in this case, I'll do x squared over x minus 2 squared equals 1. Well. We're gonna multiply, we get x squared equals x minus 2 squared. Which was the x squared minus 4x plus 4. If I subtract x squared from both sides. I get 0 equals. Negative 4x plus 4. If I add 4x to both sides, I get 4x equals 4. And I get that it crosses at x equals 1. That was when y equals 1, so putting that together, it's gonna cross at 1, 1. Let's speed up the derivatives a little bit, that's a quotient rule, I'm just gonna give them to you. F double prime or f prime of x is negative 4x over x minus 2 cubed. And f double prime of x is gonna be 8 times x plus 1 over x minus 2 to the 4th. Looking at our derivatives now. Points we have to look at are where the top or bottom equals 0. So like if we set equal to 0, we're gonna find x equals 0 is a critical point. But where the bottom equals 0 is also a critical point, stuff can change. So maybe we do. -1 and 1 and. 3 if you'd like. We look at F prime. I've got -4 times -1. Over a negative number cubed. I have 5 negatives. This is a negative region. If I stick in 1, I've got -4 times 1. Also over a negative cubed. Here I have 4 negatives, 3 from the cube and 1 from the -4. An even number of negatives is positive. We do 3. -4 times 3 over a positive cubed. It's gonna be negative. If we look at our behavior, we're coming down and we're going up. So we have a min at 0. And this is going up as we approach 2. And it's coming down as we go away from 2. It looks like our horizontal asymptote is gonna have both positives. Positive infinity on both sides. We can do the limit as x approaches 2 from the left and from the right to confirm that. So that's, if it's increasing as it approaches 2, it can only be going up. Which means it should be going towards positive infinity. And coming away from 2, it can't be negative if it's already at negative infinity, so it's gotta be coming from up top. If we look at the second derivative. Our inflection point should be at x equals -1, where the top equals 0. Inflection point. Where is that at? F of -1 is -1 squared. Over -1 minus 2 squared. Like 1/9. So -1 and 1/9.
Where's the -1 squared?
I'm plugging in the f of x up here.
Oh, okay.
And if we do a sign chart around -1. For our second derivative. The bottom is always positive because it's to an even exponent. So we're just looking at the top. If we have like -10. This is negative. So concave down. And then -1, we're gonna like, we change, maybe go to 10 or positive. It's gonna be plus or concave up. So we kind of have everything we need to sketch the curve. I'll let you all write all that shit down and we'll apply it to the graph and be done. We will continue 4.3 more on next Tuesday, because there's not Tuesday, but
Thursday.
next Thursday. This Thursday, we're doing that group practice test. Next Tuesday, we're doing the test. So we'll come back to this in the graphing on, like, over a week away. And we'll definitely be doing more of these then. Let's take a look at our graph. So we said we had an intercept at 0, 0, 0. And we had a vertical asymptote at x equals 2. We had a horizontal asymptote at y equals 1. We had critical points at 0 and 2. And we showed that we said it crossed at 1, 1. This is where we crossed our horizontal asymptote. We did that right here. We had, this was a min. And this was going to infinity. And maybe I'll put in -1 because that's where our curvature changed. Our inflection point. So it's got to come down, go through this. It's got to hit 0. It's coming up. And it was concave up to the right of that. To the left of it, it's concave down. And it's approaching that. And over here, it's doing some shit like this. So finding out where we cross the horizontal asymptote, notice it tells us we only cross it once. So we know we don't cross it out here. And if we crossed it out here, we would have to go down and like back up. And that means we would have another spot where the derivative equals 0. So we know it doesn't cross it anywhere else. That should be the graph of x squared over x minus 2 squared. And I'm over time. Thank you for your day. Have a good day. Practice that group practice test before we go in on Thursday. Godspeed. Godspeed. That's not a very nice one to say, Mr. Jones. I gotta do some shit like that.
Isn't that like good luck, don't die?
Yeah.
Oh, yeah.
I mean,
It's your version of good luck, I guess.
it's my version of good luck, but it's a test, so it's gonna be rough.
It's your sense, so you're gonna push our limits. Both
Hopefully you feel good.
mathematically and literally.